Hello, everyone. In this lecture, we're going to look at the hypothesis testing on the population mean, variance unknown. In the previous exercise, we know the population variance, sigma, is given. So that is the first case. Okay, the population variance is given. So this one is given. Now, we're going to look at the second case. If we are not given the population variance, then how do we test the hypothesis? So here, in this exercise, I'm going to take the 2009 Prius as an example. And how much time does it need to accelerate from 0 to 60 miles per hour? You see, 2009 Toyota Prius boasts an EPA estimate fuel economy of 48 mileage per gallon in the city and 45 mileage per gallon on the highway. However, it also supposedly could go from 0 to 60 miles per hour in an average of 10 seconds. This is what's claimed by Toyota. Now, if you are an engineer and you tried the Toyota, those are all the data you connected, try to go from 0 to 60 miles per hour for how many cars? So here you have 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's about 40 cars. And then you go from 0 to 60. You try to see whether you believe the claim from Toyota or not. Now, from this set of data, let's calculate some useful information. We know X bar. We can get X bar, right? 10.216. And we also know we don't know the population variance. We only know the sample variance. Sample variance is 0.2320, and then sample standard deviation will become 0.4817. Now, do you believe the claim from Toyota? We need to formulate our hypothesis. Let's formulate our hypothesis. First step, formulate hypothesis. That is H naught. What is H naught? H naught is mu equals to 10 seconds. Alternative, mu doesn't equals to 10 seconds. Step 2, calculate the test statistic. Now, this will be t-distribution. As we know, now we're going to replace sigma with s. So this will be x bar minus mu 0 divided by s over square root of n. And this will become 10.216 minus 10 divided by 0.4817 divided by how many cars we test? 40. So this will equals to 2.836. Now, let's do the critical value approach. What is T alpha, critical values? Let's get critical values. So for this one, it's still we have this distribution, T distribution. Okay, T distribution is also symmetric. You have 0, and now you have alpha over 2 in this side, and alpha over 2 in this side. This will be T alpha over 2 n minus 1, and then T alpha over 2 n minus 1 minus. So what is T alpha over 2? n minus 1. You see here, we are not given any significant levels. Just as in the real world practice, I mean, you are the engineer, you're going to make a decision what kind of alpha you use. So we are going to use 0.05. This is commonly used values, 5% significant level. And we have 40 samples. So this will equals to 0.025 and then 39, this will equals to 2.022. And you can get these values by checking the table or use the software. Now, we're going to make a decision. What is our decision? This is a two-tailed test. You are going to reject H0 if your T0 is less than minus T alpha over 2 and minus 1, or T0 greater than T alpha over 2 and minus 1. Obviously, our T0 is greater than T.02539. That's because 2.836 greater than 2.022. Therefore, we reject the H0. That means this claim is not right. Okay. Now, would your conclusion change if the average of the above samples was 10.85 seconds? Why and why not? Obviously, we need to recalculate our x bar minus mu 0 divided by s over square root of n. So this will equals to 10.85 minus 10 divided by 0.4817 over square root of 40. So it equals to 11.16. Okay. And this is still greater than T alpha over 2 and minus 1. So you still reject H0. So there's no change. Now, what if the sample size is n, standard deviation s, and average is x bar? Develop a general procedure to determine if you believe the manufacturer or not. So general procedures, first step, step 1, formulate hypothesis. That is mu equals to mu 0, or mu doesn't equals to mu 0. Step 2, compute the test statistic. That is T0 equals to x bar minus mu 0 divided by s over square root of n. You see here, the only change from the previous test statistic is you change the sigma to s. Then this will become T distribution. And step 3, and you are going to find critical values. Or p-value. So the critical value is minus T alpha over 2 and minus 1, and T alpha over 2 and minus 1. Now you are going to step 4. For two-sided test, you're going to reject H0 if T0 greater than T alpha over 2 and minus 1, or T0 less than minus T alpha over 2 and minus 1. In other words, you have a distribution, and you have T alpha over 2 and minus 1. This is alpha over 2. This is 0. This is minus T alpha over 2 and minus 1. And then you will have 1 minus alpha in the middle. And this will be your acceptance region. Accept. This will be rejection region. This will be your rejection region. And you want to check out where your T0 is, whether it's On this side or this side, or this side or in this side. So this will help you determine where you want to whether you want to reject or accept your null hypothesis. Okay, so this is the end of this exercise.